Hello friends, so this is the fourth question that we'll discuss related to determination of the output of a given logic circuit. So again, this logic circuit, it consists of only AND gates and OR gates, but it is distributed throughout. So again, in order to determine this the output of this circuit, we have to divide it in layers and levels, and then we have to finally reach the final level. So in the first level, we have these three gates: the AND gate, the OR gate, and again the AND gate. Then in the middle level, we have this AND gate, okay, and then at final we have this OR gate. So the first level, the first layer, to this AND gate, the two inputs are A, B, so the output will be A and B. Here, to this OR gate, the inputs are B and C. Okay, so the output will be B or C of this OR gate. To this AND gate, the inputs are C here and B. So the output of this AND gate will be B, C. Now, this middle level, this AND gate, the two inputs are B or C and BC. So the output will be B, C and B or C. And here it is AB. So the two inputs to this OR gate here are AB and BC and B or C. So the output will be A, B or BC and B or C. Now if we want to further simplify it, it will become A, B or B, C, B or B, C, C. We know that when two same signals are ANDed together or OR together, it will result in the same. So it will be A, B or B, C. B and B will become B, and here C and C will become C, BC. And again here BC or BC, it will result in BC. So it will be AB or BC. Okay, so the final output, we have just simplified it. So this is the output of this logic circuit. Okay, this is the fourth question. Okay, so this is the fifth question that we'll discuss about the logic circuit output of this given logic circuit. Again, it consists of NOT gate or inverter, AND gate, OR gate, and again AND gate at the final level. It consists of first, second, third, and this final fourth level. So the output of this circuit, first level, the signal A is given to this NOT gate or inverter, so it will be A complement. Now at the second level, to this AND gate, the two inputs are A complement and B. So the output will be A complement and B. At the third level, the inputs to this OR gate are A complement and B and C. Okay, so it will become A complement B or C. So at the final fourth level, the two inputs are A complement and B or C and D. Okay, so it will become, the final output will be A complement B or C into D. Okay, so this logic circuit it consists of 4 different levels, and each level had a particular logic gate, a basic logic gate, NOT gate in the first, AND gate in the second, OR gate in the third, and again an AND gate in the final level. And we determined the output of each logic gate, and then we finally moved on to the final level and we got the final Boolean expression. Okay. Okay, so this is the 6th question that we'll discuss about determination of the output expression of a given logic circuit. So here, this circuit, it looks a little bit tricky, a little bit complex, but it's very easy. This logic circuit, it consists of NOT gates, 3 NOT gates, 2 AND gates, and 1 OR gate in the final stage. So again, we can divide this circuit into 3 levels. In the first level, we will deal with the 3 NOT gates or inverters. In the second level, we will handle this 2 AND gates and then the OR gate at last. So, the first level, this first NOT gate or inverter, it has input A. So the output will be A complement. Here, the second NOT gate or inverter, the input is B. So it will be B complement. And this, the third NOT gate or inverter, the first level, will be, the input is C, so the output will be C complement. Now, this is a 2 input AND gate. In the second level, the first AND gate is a 2 input AND gate. The inputs are A complement and B. Okay, here B, the 2 inputs B and A complement. So the output will be simply A complement and B. This is a 3 input AND gate. The inputs are, first input is A, the second input is B complement, and the third input is C complement. First input A, second input B complement, third input C complement. So the output would be A, B complement, C complement. Okay. Then the final OR gate. At last, the final level, the 2 inputs are A complement and B, and A and B complement and C complement. So it will simply be the sum of these 2 values, A complement and B, or A, B complement, C complement. Okay. So this is the final output. So this, at first, if you look at this logic circuit, it will look a little bit complex, but always don't try to solve this logic circuit all at once. Okay, if you do in that way, it will be confusing. So always you have to divide the circuit into layers, into levels. You have to separate them, then solve one layer, go on to the next level, solve that, then go solve the next, and then reach the final level. So here the first level, we divided it, the NOT gates. Then in the second level, the 2 AND gates, one 2 input AND gate and another 3 input AND gate. Then at the final level was this OR gate. So always proceed in this way, it will be a little bit easy. Okay. So this is the 6th question that we have discussed.